Hello class, it's Mr. Cablan speaking, and I'm here to do a video annotation. Basically, I'm just going to go through the lessons that we should have been going through in class today for chapter 6. And as you can see, there are 3 lessons for this chapter. So as we go through the notes here, I'm just going to quickly go over some other key details which are not on the notes, just to clarify any explanations that you might have trouble with. So if you take a look at today's lesson, we are going to be looking at what are called non-linear relations. Now, before we begin here, you're probably wondering, what exactly is something that is non-linear? Well, that's what this lesson's about. Okay, just remember from a couple of chapters ago, what a linear relation is anything that involves a straight line. So what we're going to see for today is obviously something that is opposite to that. So what exactly is a non-linear relation? Well, basically, what we have to understand about non-linear is that it's anything that is not a line. Now, what you can see here in the first sentence, it says a quadratic relation is one type of non-linear relation. Okay, so there's a fancy word there, which is a quadratic. So what is a quadratic? Well, a quadratic is once you start drawing it, we're going to draw what's called a parabola. Okay, this word over here. And what a parabola is, it's a U-shaped curve that looks exactly like this. And for the most part, for all the parts here, there's actually 2 ways that a parabola can open. It can either open upwards like this, like a U, or an upside down U. And those are the only 2 ways that a parabola can open. Now, if you take a look at the second arrow here, it says an equation of the form y equals ax squared plus bx plus c represents what's called a quadratic relation. An easier way to remember that is if you take a look at an equation and you notice one of the x's has an exponent of 2 attached to it, that automatically tells you that what you have there is an equation of a quadratic relation. All right, so let's take a look at some examples and take a look how we can draw this over here. So for the first example, what we want to do here, it says to draw a line or curve of best fit. So what we want to do here, using the table of values, is to plot each one of these as a point and see exactly what we have. So remember that when you're plotting points on a grid, okay, the first value here is the x, and the value directly across from it is what's called the y coordinate. And together, what they are is an ordered pair, which you spent a lot of time with on back in your grade 9 class. So for this point over here, for 0, 2, we start at this point here at 0, and we go up here to where it says 2. So that's our first point. Okay, our second point here is going to be 1, 6. So I'm going to go right 1, okay, and then up 6, or up to where it says 6, because each of these boxes here is going up by 2. Next one here, we're going to plot the point 2, 10, which is right 2, and then up 10. Okay, and next one we have here is 3, 14, which is right 3, and then up 14. Okay, and we can just finish these off. You can probably see the pattern here. We're gonna go right 4, and then up 18 over here. And last but not least, we have right 5, and then up 22. Now, for looking at this from a distance, you notice that these 6 points can easily be drawn with a straight line, just like this. All right. So what we have here is an example of a linear relation, and the reason for that is because we can draw a straight line through all of these points. Okay. So if you recall, back in grade 9, you spent a lot of time on that, and we spent about 2 chapters of that in this course. So what exactly is new for this lesson here, and what exactly is a nonlinear relation? So if you take a look at this next grid, or next table of values, okay, notice we're still using the same grid just to make a comparison. What we want to do here is graph these exact same way like we did this previous example. So just like the previous example over here, we're going to start off with 0, 24. So from 0, I'm going to go up to 24 over here. Okay, for 1, 6, we're going to go right 1 and then up 6. Okay, then we have 2, 0. Okay, then we're going to go right 3 and then up 6. Okay, and then we're going to go right 4 and up 24. Now, what you can see here is totally different from what we saw in the last example here. And these points over here, you're going to just use a freehand drawing of a curve, and it looks something like this. All right. So it says here, draw a line of curve of best fit. And as you can see, we have a curve. And the reason why we did that is the fact that when we do that, we can't draw a line through all the points, okay, unlike the previous example. So what we have to do here is to connect those 5 points there with a smooth curve. And that's exactly how you draw a graph of a quadratic relation. And again, this U-shaped curve is called a parabola. All right, moving forward, let's go to the next example. We're actually going to do some calculations behind this. And we're going to look at the calculation using the square function on your calculator. If you remember, it's an x squared key if you have a calculator in front of you. So it says here, the formula for the area of a square is a equals s squared, where s represents the side length of a square. Now in the table here, all we have here are values, which we're going to take and just simply just square them. And we're going to go do this step by step. So for example, if we have a side length of 0 and we put in for the s here, what we get here is 0 squared. Okay, and if you put that in your calculator, you get 0. Okay, next one here, we're going to take 1 and square it, and that gives us 1. We're going to take 2 and square it, okay, and this will give us 4. Okay, and you can pretty much see what we're doing with each number is we're just taking each number and then raising it to the exponent 2 or pressing the x squared key in your calculator and pressing equals. So 3 squared gives me 9, 4 squared gives me 16, and this last one over here, 5 squared, will give me 25. Now, just like the previous example, each of these is going to be an ordered pair. Now, on the right side here, I'm just going to put down the points. You can see exactly what the points are when we plot them on this grid. So what we have here is 0, 0, 1, 1, 2, 4, 3, 9, 4, 16, and 5, 25. Okay, and you're going to see something a little bit different for this one. So starting off with 0, 0. Okay, so don't forget to label the axes there very quickly. So we have 0, 0, okay, and then 1, 1. Okay, now you're probably looking at, well, we have these 2 points here. They look like they're going to form a straight line. Well, let's see what happens next. So we have 2, 4, and you can see already it's starting to change direction, changing slightly more upwards as we go along. And then we have 3, 9. Now you can already see if you put a ruler on your screen, okay, feel free to do that if you want. Okay, you will see that these 4 points no longer form a straight line. Just to finish this off, we have 4, 16, and then 5, 25. Okay, so again, you can see over here that we can no longer connect these 6 points here with a straight line. So how in the world are we going to connect these points? Well, we're going to connect it with half of a curve, just like that. All right, so you can now see how to draw a nonlinear relation given a table, and then you can now see the difference between a linear relation, which gave us a line, and a nonlinear relation, which gave us a curve. And that wraps up today's lesson. Don't forget, you can print out the review sheets from the LMS or the website, and you can use those in lieu of the textbook questions. And if you have any questions, don't hesitate to ask. See you in the next lesson.